Hello Zarówka, good morning, good evening, good afternoon. This is our first video lesson. I've prepared few lessons for different groups and the feedback is nice. Students say that it's working, it's a good method, so I'm going to present material in such a way. Last lesson we were talking about optical microscope. Okay, typical optical microscope. You wrote a kind of test about image formation, about magnification, about the smallest detail which can be seen by optical microscope. Remember, as a revision, remember that optical microscope uses a light, moreover visible light. Okay, so the smallest detail which can be seen is measured in hundreds of nanometers. Let's say 500 of nanometer. Nano, as you know, means 10 to the power of 9, so order of magnitude of such microscope is around 10 to the power of 7 meters, which means that the smallest detail which can be seen is around 10 to the power of -7 of meters. The phenomenon which limits resolution of microscope is known as diffraction. Okay, if we use the best optics, if we use the best lenses, then we cannot see details smaller than 10 to the power of -7 of meters, because light which is used in this microscope has a wavelength measured in hundreds of nanometers, so order of magnitude is 10 to the power of -7 of meters. Okay, so it was a revision. So today I'm going to talk about electrons microscope, what are differences, and what is the physics of typical electron microscope. Okay, so electron microscope is a little bit more advanced device, which uses not visible light but stream of electrons. Okay, so what is the difference between stream of electrons and visible light? Oh, it's a huge difference, because each moving particle has a corresponding wave of wavelength given by theory of hypothesis called de Broglie. Okay, so de Broglie 100 years ago said that if we have a particle which moves, then we can calculate something like corresponding wavelength of wave associated with moving particle. So in one side we have a moving particle which has mass and travels with velocity v. On the other hand, this particle has an equivalent of kind of wave of specific certain wavelength, and this wavelength depends on the momentum of the particle, so of two quantities, its mass and its velocity. Okay, so basically, if you have particle which travels with certain speed, then this particle has associated wave of wavelength given by the Broglie equation. I will present this equation in one moment. But this wavelength depends on the mass of the particle and velocity of the particle. So any moving particle has something like a wavelength of a wave of given wavelength. So we can say that particle behaves as a wave. So in this case, in electron microscope, electron, a tiny particle, like a little marble, behaves as a wave like a light. Okay, and de Broglie connects by equation the world of particles with world of waves. Okay, and he said that each particle has a wave of wavelength, lambda is the symbol of wavelength, which is related with a kind of constant called Planck's constant, and this parameter called momentum, where Planck constant, as I said, is a constant and is equal to 6.63 times 10 to the power of -34 joule second. This is the unit, you don't need to know the unit, you don't need to memorize this constant. And this small p is a momentum, and this momentum depends on the mass and velocity. Basically, it's a product of mass and velocity. So for any particle of certain mass which travels with certain velocity, you can calculate wavelength of the wave. Okay? So today I'm going to present what is the wavelength of typical electron accelerated in electron's microscope, and what is the resolution of electron microscope compared with resolution of typical light. Okay? So stop video for a moment. Please copy this to your notebook. When you will be ready, you can turn it again. Okay, few more words about light. How do we know that light limits our resolution? As I said at the very beginning, visible light is an electromagnetic wave of wavelengths from range around 400 nanometers up to 700 nanometers, which corresponds with violet or blue light up to red light. So basically, if you have a rainbow, you can observe colors, yes? Each color represents wave of visible light, electromagnetic wave of different wavelength. If colors are red, it means that wavelengths are longer than our colors like blue or violet. Okay? So what is the conclusion? Violet light or blue light, okay, is better in the case of details than red light because has a smaller wavelength. Oh, this is why Blu-ray is better than DVD. On Blu-ray we can store more data because details which can be visible by laser, by sensor, can be smaller. Yes, 400 nanometers in the length. In the case of typical DVD where red light is used, details are much more bigger, which means that less details can be stored on the same surface area, which means that less data can be stored on the disk. Okay, so in the case of Blu-ray we can store more data because details are less, because violet or shorter light is used to read it. Okay, so normally, logically, for stream of electrons, the wavelength must be much more less than hundreds of nanometers because details which are seen by typical electrons microscope are much more less. Okay, so copy this to your notebook. On next slide we will calculate based on physics, yes, unfortunately physics, but base physics, the equations you have to know. Based on physics we will calculate the wavelength of typical electron in optical microscope, and due to this you can compare what is the magnification of electrons microscope compared with typical optical microscope. Okay, ready? And so next you can name a point physics in electron microscope. Okay, let's imagine that you have an electron, okay, a tiny particle, okay. Electron is something which is charged, so it has a negative charge. If you want to move electron, if you want to accelerate electron, if you want to gain energy of electron, you have to place it in electric field. So you can imagine that somewhere there is a positive charge which attracts this negatively charged electron. Okay? So this something can be represented by electric field of given voltage. So basically, if electron is placed in the potential difference, so in voltage, it accelerates. Okay? So let's imagine that we have a problem. Your task is to find wavelength of electron. If mass of the electron is given, I'm a physicist, so I remember mass of electron is 9.11 times 10 to the power of minus 31 of kilograms, and this accelerating voltage is also given. Let's imagine that electron in my microscope, imaginary microscope, is accelerated by a voltage of 1000 of volts. Okay? First of all, you have to find energy gained by this electron. Okay, electron accelerates, so its energy is bigger, bigger, and bigger, and bigger. This energy related with motion is known as a kinetic energy. I'm going to use a symbol of Ke, kinetic energy. When electron of charge Q is placed in potential difference V, then its kinetic energy is equal to Q times V. So we need one more data, charge of electron. Charge of electron is also known, and I also remember charge of electron is 1.6 times 10 to the power of minus 19 of coulombs. So first you have to do is to calculate kinetic energy of accelerated electron. So 1.6 times 10 to the power of minus 19 of coulombs, which is a charge, multiplied by 1000 volts, which is a potential difference. 1.6 times 10 to the power of minus 19 times 1000 is 1.6 times 10 to the power of minus 16 of joules. Joule is a unit of energy, as you know from your middle school. Okay, so one single electron is placed in the potential difference of 1000 volts, it gains energy by 1.6 times 10 to the power of minus 16 of joules. Okay, so it was first part of solution. Second part of solution is find momentum. Okay, there is an equation linking kinetic energy with momentum, but I hope that you remember kinetic energy from your middle school. It's mv squared over 2. I'm going to write this in a little bit different form. In m squared v squared divided by 2m is the same because always you can cross this mass obtaining mv squared over 2. What is m squared v squared? It's momentum squared, because as I said at the beginning, momentum is a product of mass and velocity. Okay? So this equation in easy way links momentum of the electron with its kinetic energy. We are interested what is the momentum. So by rearranging equation, we can write that momentum is the square root of 2m times its kinetic energy. Okay? Mass is given, kinetic energy is given, so we are able to calculate momentum of the accelerated electron. So 2 times 9.11 times 10 to the power of minus 31, it's data given by me at the beginning of the exercise, times kinetic energy, which is 1.6 times 10 to the power of minus 16 of joules. This is something we've calculated few seconds ago. I have calculator, please calculate this. And let me check what is a result. I'm not prepared, I don't know result. I must turn on my calculator and calculate it. So what is it? So this is the square root of 2 times 9.11 times 1.6. Okay, and the power is 10 to the power of 40 minus 47 times 10 to the power of, in brackets, minus 47, because minus 31 minus 16 is minus 47, and the square root, where is square root on this calculator? The square root of the answer is, I have the answer, 9.98 times 10 to the power of minus 24. Momentum has a unit of kilogram times meter squared over meter per second, because this is mass times velocity. Okay, so we finished second step, and now the last part. The question was about wavelength of electron. Wavelength of electron is given by the Broglie equation, Planck's constant divided by its momentum. Planck's constant is a constant, you can find it in any physics table with physics constants. I remember it's 6.63 times 10 to the power of minus 34 divided by 9.98 times 10 to the power of minus 24. Again, I'm going to use a calculator to solve it. 6.63 divided by 9.98, which is 0.66 times 10 to the power of minus 10 of meters. So when electron is accelerated by potential difference of 1000 volts, the details which can be seen are in the order of magnitude of 10 to the power of minus 10 meters. Oh, maybe a little bit more precisely, it will be 6.6 times 10 to the power of minus 11 of meters. But this 1000 volts is the upper limit of accelerating potential difference, so usually it's around 10 to the power of minus 10 of meters. Okay, so I've presented the method. Please copy this, stop the movie, copy this to your notebook. I will present step by step one more time, but let's conclude this. When you will be ready, turn movie again. And next slide I'm going to compare visible light with electrons microscope. Okay, so this is a conclusion. If you have typical light microscope, optical microscope, okay, then in optical microscope we have a light which illuminates objects. Light has a wavelength of 10 to the power of minus 7 of meters, so details which can be seen are equal to 10 to the power of minus 7 of meters. In electron microscope uses not light but stream of electrons. Each electron has associated wave of wavelength given by de Broglie equation, and it results in wavelength of 10 to the power of minus 10 of meters. So details which can be seen by typical electron microscope are 10 to the power of minus 10 of meters. So what is a difference? Okay, the difference is 1000 times. Resolution of electron microscope is around 1000 times bigger than the resolution of optical microscope, because details which can be seen as around 10,000 times smaller. So electron microscope can produce magnification which is 1000 times bigger than magnification of the best optical microscopes. Okay, so this is the conclusion, please know this. On next slide I'm going to present the method how to calculate wavelength of accelerating electron one more time. Okay, so the shortest version. First of all, you have to find what is energy, kinetic energy of electron by multiplying its charge times voltage. Secondly, you have to find momentum of accelerated electron by multiplying 2 times mass times kinetic energy and the square root of this. Finally, you have to find wavelength of wave associated with electron by using the Broglie equation, where h is a Planck constant. Of course, mass, charge and Planck constant are given. You don't need to memorize that mass of electron is 9.11 times 10 to the power of minus 31 kilograms. Charge of electron is 1.6 times 10 to the power of minus 19 of coulombs, and Planck's constant is 6.63 times 10 to the power of minus 34 joule times second. Copy this. You have to know method, you have to know how to calculate, of course, by using calculator. You don't need to memorize constants, but you have to know how to find wavelength of associated wave of any particle, charged particle, accelerated by given potential difference, because this is the base how electron microscope works. Okay, so let's finish this lesson now. I hope that the method of presenting is not bad. Please write comment to me. You can write comment on YouTube or by email. Okay, see you next lesson. Bye.